Today, we'll look at optimization techniques and new management tools. Optimization techniques are very important. The term optimization, or to optimize, is simply to find the best price, the best quantity that will either maximize your revenues, maximize your profits, but minimize your costs. So anything good is maximized, anything bad is minimized. You can never want to maximize costs. So this is what we call optimization. So we'll look at the methods for maximizing and minimizing an objective function. And there are three objective functions that we'll really consider. Number one, the revenue function, which is denoted by TR. Number two, the profit function, which is denoted by pi. And number three, the cost function, which is denoted by TC. The general term for each of these treatments is called optimization. But we are maximizing total revenue and profit. We are minimizing the total costs. Other functions that we're going to learn how to optimize are utility. Utility, you are maximizing it. Profits, you maximize them. Costs, you minimize them. So we'll start with what is called our total revenue function. Total revenue function is given by price times quantity. So whenever we're dealing with total revenue, we're looking at sales that are increasing. So from 0 to 1, we have 90 sales. This is typifying 90 sales. From any additional unit that we add on the total revenue is called marginal. So from 90 to 160, we have added how many units? Or how much of the revenue has been gained? 70. From the additional unit that we're having from 160 to 210, we're adding how many units? 50. So this increment by 1 unit gives additional increments in the total revenue. So these additional units are called the marginal revenue. Marginal revenue. It's increasing at a decreasing rate. We call this rate the marginal rate of diminishing returns, increasing at a diminishing rate until you reach a certain point, you start going down. So if you're going to use the table, I want you to understand basically how to come up with the average, marginal, and the total revenue. So if our price here is 90, here it's 80, here 70. Total revenue is price times quantity. So 0 times 0 is 0 here. 90 times 1 is 90. 80 times 2 is 160. And 70 by 3 is 210. I hope you're seeing the trend of what is happening there. So this is how we find our total revenue function. Are we seeing that? Then average revenue is simply when we divide our total revenue by the quantity. So 90 divided by 1 is 90. 16 divided by 2 is 8. 210 divided by 3 is 70. If you can observe, the average revenue is the same as the price, especially for a perfectly competitive market. Then the marginal revenue is the additional units of the total revenue. So from here to here, we have 90 units. From 90 to 160, we have 70 additional units. From 160 to 210, we have 50. So this is called our marginal revenue. It's a change in total revenue over the change in the quantity. So I now need you to fill in the blanks. Please, these classes are interactive. I'm going to give you just 5 minutes or less so that you can try out something. I want you to fill in and give me the total revenue function, the average revenue function, and the marginal revenue. So I'm going to broadcast what I'm doing here. So there's a price and the quantity here. I want you to find the total revenue. I want you to find the average revenue, and I want you to find the marginal revenue for the following. Here you're given price 10, 20, 30, 40, 50, 60, 70, and we have quantity here 1, 2, 3, 5, 6, 9, and 10. So quickly, without embarrassing me, find the columns that I have asked you to fill in the columns. I'm going to give you 2 minutes and I'll get back to you.
Before you go, can I just see the previous slide where the example of the same is?
Okay. This is a previous slide. We have the quantities in this column and the total revenue. The price.
No, actually, just wanted the formulas.
Okay, you can screen grab.
Yes, done.
All right. So I'm only giving you just 3 minutes. Okay. Okay, so total revenue, I will ask that you complete it. Hilda, Joyce, and Maureen in that order. Total revenue, what are we having here?
10.
What's the formula for total revenue?
It's price multiplied by quantity.
Okay, 10, then here?
40.
40.
Mhm.
90.
90.
Mhm.
200.
Mhm.
300.
300.
Mhm.
540.
5,
40.
40. Then,
700.
7.
okay. Next team, Chewe, Yamikani, and Kobe in that order. AR, how are you finding AR here?
AR is TR over Q.
Mhm.
And the first one is 10,
Mhm.
10,
Mhm.
30,
Mhm.
40,
Mhm.
50,
Mhm.
60,
Mhm.
and 7.
And what?
7.
7. Okay. Is she correct? Are these correct?
No,
Isn't the
7
second one? Isn't the second one
is
supposed to
different.
be 20 and the last one 70?
70.
20 and 70 here. Okay. So you discover that the average revenue is similar to the price often. Okay. Then how do we find the marginal revenue? Change in what? In total revenue over change in quantity. Okay, so here what are we having? The first one is a dash, right? Then here?
$30.
Okay, Hilda, Joyce, Maureen. Here we're having what? 30. Okay. How did you get the 30? 40 minus 10 divided by 2 minus 1. That is 30, yeah? Next. The change between these two.
90. 90 minus 40.
Divided by
Divide by
3.
1.
3 minus 2, which is 1. Okay, so what's the answer?
50.
Then here.
$200 minus 90, which is 110. Divide by 5 minus 3, which is 2. So the answer is 55.
Okay, and here?
300 minus 200, which is 100. Then divide by 6 minus 5, which is 1. So the answer is 100. 540 minus 300. Divide by 9 minus 6, which is 3. So the answer is 8. Then 700 minus 540. divide by 10 minus 9, which is 1. So the answer is 1/60.
For that. So basically, if you're using the manual way, that is how you find, all right? That's how you complete this equation. So sometimes you could use the function you're given to tabulate the figures if you're given a function. So total revenue looks like this. These are the graphs of total revenue. Marginal revenue is usually half of the average revenue. So if this is cutting at 5, this one will cut at 10. If it's cutting at 4, the average revenue, the marginal revenue cut at, if it's cutting at 2, here to cut at 4. So this is how the curves look like. Okay, so now we go to the cost functions. The cost functions are, we have what we call the total cost, average cost, and the marginal cost. Our total cost is made up of the fixed and the variable cost. The total fixed cost is constant. It does not depend on output. The variable cost is variable. It changes with output. Anything divided by quantity is called average. Remember, in this case, we divided the total revenue by quantity. It's called average revenue. Any change or incremental change is called marginal. So the incremental change in total revenue is called marginal revenue. So total cost divided by quantity is called our average costs. The change in total costs of a change in quantity is called our marginal cost, the additional costs we have. So if you have 0, 1, 2, 3, 4, 5, and total cost is 120, 140, 160, and 48. The difference from here to here is marginal. So this is 120, from here to here it's 20, from here to here it's 20, from here to here it's 60, and 240. So these are called marginal, the increments in the total cost function. And when we divide this by the quantity, what we get is called the average. So 160 divided by 2 is 8. 180 divided by 3 is 60. So these are what we call the average cost functions. So under cost theory, you need to understand how these curves look like. Usually, if you have the average cost, the marginal cost will cut in between. This is how the costs look like. So costs have a certain flow. They have an autonomous part here. If the cost is touching the intercept, this is called a fixed cost. So 20 is a fixed cost. Okay, there are costs that do not depend on output. They are constant. Whether you produce or not, you spend rentals. So if this was our function here, our fixed costs would be 180 here. So the total cost functions are usually U-shaped in nature. They're usually U-shaped in nature. So the slope of the tangent to the total curve at the point is equal to the marginal value at that point. So when we are maximizing our marginal revenue, and the marginal cost will always be equal. This is what we call the maximization point. So now, after doing the manual way, we're going to do the calculus way. But before I do the calculus way, we know that profit is excess revenue over costs. So we have excess revenue, we call that a profit. So a profit is negative when the total costs are more than our total revenue. Profit is negative, we call it a loss. When the revenues are more than the total cost, the profits are positive. When the profits are positive, we call it a profit, an economic profit. So we have our total revenue functions here and our total cost functions here. So 0 minus 20, we get negative 20. 90 minus 140. So using these functions here, you're able to tell that the negative parts here are the losses. So if you have functions, I showed you that total cost always looks like this. Total revenue always looks like that. Then our total costs looks like that. So as long as the total revenue is more than the total cost, this is called a profit. As long as the total cost is more than the total revenue, these are losses. So using a graphical illustration, the point at which the total revenue is tilting here, it's going down. This is the point where we maximize what? Maximize revenue. Revenue is maximized at the point where the curve is going downwards. But where the curve is big, where the gap is big between the total cost function and the total revenue, we call that the profit. So this is the highest profit from C to J. At this point, this is where you have the highest line. So the profits will range between point B and point D. The losses will be any point below point B. These are losses because this total cost is more than the profit. These are also losses. So the range within which the profit is made is between 2 units and 4 units. If you produce more than 4 units, just know that the firm is going to make a loss. If you are producing less than 2 units, the firm also make a loss. So the point where total revenue is equal to the total cost, we call that the break-even point. You neither make a profit nor a loss. You're at par. Firms exist in 3 main reasons. Number 1, for profit maximization. So profit is maximized at 3 units. This is point number 1. Firms also exist for revenue maximization. This is sales maximization at E. Mind you, this is not the point where you're maximizing your profit. You're just maximizing your revenues. And thirdly, firms exist to break even. The behavior of leaving to break even is called satisficing behavior. Satisficing. So the tendency that firms have to exist just to break even is satisficing, not satisficing in short. So if you're using the profit function here, you'll see that profits are only between 2 and 4 units and maximized at 3 units. Below 2 units, these are losses. Above 4 units, these are losses. So this is a profit function. So the firm will maximize their total profit at Q is equal to 3, where profit, where the positive difference between TR and TC is the greatest. That is the point where marginal revenue is equal to the marginal cost. So the steps in optimization. Number 1, define the objective function. Number 2, define one or more constraints of the values of the function, then determine the values of the choice of the verbs that maximize or minimize the function. So I'll summarize these steps my own way. Step 1, define the function. Or in a layman's language, you say find the function. Number 2, differentiate. Number 3, equate to 0 and solve for what? Solve for Q and price. So equate to 0, then number 4, solve for P and Q. So let's use the 4 steps of optimization to optimize the following 2 functions. So suppose I have P is equal to 2000 minus 2Q. This is my price function. Then my profit function will be 120 minus 2Q squared. So we want to maximize or optimize profit and optimize our revenues. So step 1, find the function you want to optimize. So we want to optimize total revenue. Total revenue is given by price times quantity. So in this case, we have our price, which is 2000 minus 2Q. So here we have our 2000Q minus 2Q squared. So we have found the function. So number 2, we need to differentiate. Differentiation, we only use the power rule. This power rule takes only a second to know. It's called dy over dx. So here we're multiplying a times n and subtracting 1 from the power. So if you have y is equal to 6x to the power 5, we're just multiplying the powers times the 6, which is called the coefficient. The power here is called the exponent. The x is called the variable. So this is dy over dx. So 6 times 5 is 30. And we subtract a 1 from the 5 to get what? A 4. This is what we call differentiation. So if you're differentiating a constant, it's always 0 because it drops out. So if you have P is equal to 170Q minus 5Q squared plus 10. Because there's a letter this side, we're differentiating the letter on the left side against the letter on the right side. So this is called the P over the Q. There's an invisible 1 there. 1 times 170 is 170. 1 minus 1 is 0. So whenever you have a coefficient with a number to the power 1, when you differentiate it, this number just drops out. So 170Q is simply 170. 100Q is 100. Q is 1 because there's a 1 which we never write. It's 1Q. 20Q is 20. Then here 5 times 2 is 10. Then when you subtract 1 from the 2 there, it's a 1. You never write 1. So this is how we differentiate. Just 3 more examples on differentiation before I go, so that I don't leave any people behind. So if you have TR is equal to 2000 Q minus 2Q squared, this will be the TR over dq. Total revenue, whenever we differentiate it, change to marginal revenue. Total cost becomes marginal cost. Total profit becomes marginal profit. So 2000 Q, like I said, if it has 1 liter to the power Q, it becomes 2000. 2Q to the power 2, it becomes 4Q. This is called our marginal revenue. And to maximize the revenue, we equate it to 0. By the way, this is a continuation of the question we're from doing. When you equate this to 0, we are solving for Q. So step 4, when this Q comes inside, we're going to have 4Q is equal to 2000. So to find the value of Q, we divide the 2000 by 4. So 2000 divided by 4, what does it give you? It gives you 500. But optimization says we need to find both the price and the quantity that will maximize the revenue. Now, our price was 2000 minus 2Q. So to find the price, we'll substitute where there is a quantity there. We'll put the 500 there. So meaning we put a 500, 500 times 2 give us a 1000. So 1000 from 2000 will give us a what? 1000. So this is the price that will maximize our total revenue. So from what I taught you, this is how total revenue looks like. So the point that maximizes this point is what? 1000. That's our quantity. Meaning if this is 1500, this other part will be what? 1000. And the price, total revenue, is given by 2000 Q minus 2Q squared. We already found our Q that maximizes is 500. And we already found our price that maximizes is 1000. So here on the price, we put 1000. Price is always on the axis and this axis. Now wait a minute. How did we find this 1000 here? At least we're aware where this Q is coming from. We're aware where this price is coming from. Never leave an exam in economics without illustrating a graph. So to plot this one here, we'll just equate it to 0. We have what? 2000 minus 2Q. Then the Q is outside here. So if we are to equate each of these ones, for us to get 0 inside, say that this Q is 0, that is where the 0 is here. Or this 2000 minus 2Q must be equal to 0. 2000 minus 2Q must be equal to 0. So when you get this to 0, we're going to have 2000 is equal to 2Q. So divide by 2 on both sides. Our quantity will now be 1000. This is where the other intercept is coming from. It's 1000 here. I'm just taking you back to grade 12. I'm sure most of you passed through grade 12 to be where we are. All right, the second question is, how do we optimize the profit? Using the same, if you're given a profit function will be 120 q minus 2q squared. We're learning how to optimize. Step 1, differentiate once. So you can use an apostrophe here to show that you're differentiating. So 120q is 120. Then this is 4q. Then equate to 0. So here we have 120 minus 4q. Then solve for q. And this comes this side will be a positive. So here we're going to have 120. So when you divide q in there, quantity was what? 30. So like I taught you, you can also graph this. 120q minus 2q squared must be equal to 0. So if you want to know how the curve will look like, factor out the q there. So here you're going to have 120 minus 2q. So either q must be equal to 0 for this to hold, or 120 must be equal to 120 minus 2q must be equal to 0. So when we have this, we're going to have to divide by 2 on both sides. So meaning our q is equal to 60. So if you're going to illustrate this profit function, know that it will be maximized here. Here we have 0. Here we have what? 60. Half of this one is a 30. That will maximize the profit. The price, since we're not given the price function, I'll not mention it here because we don't have the initial price function for it. So this is how we maximize profit. When profit exceeds 60 units, we are going to go into losses. Profits, but maximum profit happens here at 30 units. So optimization is wide. This is just a small segment of optimization. Optimization comes in utility. Optimization comes as well in production. Optimization is spread in all the topics, so you need to know. So this and many more of the other sessions, please remember to ask for the links. Most of these will be recorded.